Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. High-speed storage over the network introduces a specialized network infrastructure built for performance, scalability, and centralized control. A storage area network, often called a SAN, provides servers with access to block-level storage devices through a dedicated network that is separate from regular user or data traffic. This separation enables high-speed access to critical storage resources while reducing bottlenecks on the main network. By using SANs, organizations can pool their storage, improve redundancy, and support applications that demand fast and consistent performance. The Network Plus exam covers SAN concepts within its infrastructure and storage objectives. You may encounter questions that compare SAN to NAS, test your understanding of storage protocols, or require you to identify components used in enterprise environments. Other questions may involve determining which storage solution is appropriate for a given scenario. Understanding the protocols, layout, and purpose of a storage area network is essential for mastering storage topics and distinguishing between similar-sounding technologies under test conditions. A storage area network is a dedicated network designed specifically for transporting storage traffic between servers and storage devices. Unlike traditional networks that carry data between users and applications, a SAN carries data between a server's operating system and its disk storage, as if the disks were physically attached. The storage appears to the server as locally mounted drives, even though the actual disks may reside in another rack or across the building. Because SANs are dedicated to storage traffic, they typically deliver high throughput and low latency. Understanding the difference between SAN and NAS is critical for both the exam and real-world environments. ASAN provides block-level storage, meaning the server interacts with raw storage blocks and manages the file system itself. ANAS, or network-attached storage, provides file-level access, where the storage device manages the file system and presents files over a network share. SANs are used when high performance is needed, especially in databases and virtual environments. NAS is often used for general file sharing and backups. The exam may ask you to match scenarios to the appropriate storage solution. Fiber channel is one of the primary technologies used in SAN environments. It is a high-speed networking protocol designed specifically for transmitting SCSI commands over fiber optic or copper links. Fiber channel networks require specialized switches and host bus adapters, or HBAs, which are installed in servers to connect them to the SAN. Fiber channel is known for its reliability, low latency, and ability to handle large volumes of data with minimal CPU overhead. It is widely used in enterprise data centers where performance is a top priority. Internet Small Computer System Interface, or ISXE, is a protocol that sends SCSI commands over standard IP networks, allowing traditional Ethernet to be used for storage access. This approach is more cost-efficient than fiber channel and can be deployed using existing infrastructure. ISXE operates over TCP port 3260 and uses either software or hardware initiators to communicate with storage targets. While it does not always match the speed and reliability of fiber channel, it is sufficient for many environments and is commonly seen in mid-sized networks and virtual infrastructures. A typical SAN includes several components that work together to deliver reliable and high-speed storage access. These components include storage arrays or disk shelves, which house the physical disks, and HBAs or network interface cards on the servers. SAN switches connect these devices, forming the network backbone. Cabling, often fiber optic, provides the physical connection. All of these components are tuned for low latency and high IOPS, or input/output operations per second, making them suitable for performance-critical workloads. Zoning and LUN masking are two methods used to manage access control within SAN. Zoning is configured on the SAN switches and determines which devices can see each other. This limits unnecessary communication and enhances security. LUN masking is configured on the storage array and defines which logical unit numbers, or volumes, are visible to which servers. These two features help isolate workloads, enforce security policies, and prevent accidental data loss by restricting access to only authorized systems. Storage protocols used in SAN environments include Fiber Channel, ISCSE, and Fiber Channel over Ethernet, also known as FCOE. Each protocol offers different trade-offs in terms of speed, cost, and complexity. Fiber Channel is preferred for high-performance applications, ISCSE is used for lower-cost deployments, and FCOE combines storage and Ethernet traffic on a unified network fabric. Some environments even use multiple protocols, depending on the application. These storage protocols may run over dedicated VLANs or isolated physical networks to maintain performance and security. SANs offer several key benefits that make them attractive for enterprise environments. They provide high throughput and low latency, supporting performance-intensive applications such as databases, enterprise resource planning systems, and virtualization platforms. Centralized storage simplifies backup and recovery operations, improves disaster recovery capabilities, and allows for more efficient storage utilization. SANs also support clustering, where multiple servers share access to the same storage pool for load balancing and high availability. Despite their advantages, SANs also come with some drawbacks. The hardware required, such as specialized switches, HBAs, and storage arrays, can be expensive. Setup and configuration are complex, often requiring experienced storage administrators. Troubleshooting issues such as misconfigured zoning or failed paths can be time-consuming and require deep knowledge of both networking and storage protocols. Redundancy is critical, so most SANs are built with dual fabric paths to prevent a single point of failure, further increasing cost and complexity. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Storage area networks are especially valuable in virtualization environments where multiple virtual machines share common storage resources. SANs provide the shared disk access necessary for features like live migration, where a virtual machine can move from one physical host to another without downtime. For these capabilities to work reliably, the shared storage must offer high input/output performance and low latency, which SANs are designed to deliver. Virtualization clusters often depend on SAN storage to coordinate workloads, maintain availability, and support large-scale resource pools. Multipathing is a standard feature in SAN design that improves both redundancy and performance. It involves configuring multiple physical paths between a server and the storage array. These paths are managed by multipathing software, which balances the load and automatically reroutes traffic if one link fails. This ensures continuous access to storage, even during hardware failures or maintenance. Multipressing not only prevents downtime, but also enhances throughput by using all available interfaces to handle simultaneous I/O operations. Monitoring the performance of SAN is crucial to maintaining application health and identifying potential issues before they affect users. Metrics such as IOPS, latency, and throughput are tracked to understand how well the storage infrastructure is handling demand. Most vendors provide proprietary tools for monitoring their specific arrays and switches, but SAN performance data can also be integrated into broader network and infrastructure monitoring platforms. Real-time alerts, trend analysis, and capacity planning help administrators optimize performance and avoid bottlenecks. Security considerations for SANs begin with physical and logical isolation. Because SANs carry critical data, they are typically separated from production or user traffic through dedicated fabrics or VLANs. Management interfaces on storage controllers and switches should be encrypted and access controlled to prevent unauthorized configuration changes. Strong authentication is required for initiators and targets, and logging should be enabled to track access attempts. These practices protect against data breaches and misconfigurations that could compromise data integrity or availability. Troubleshooting SAN connectivity requires understanding the relationship between initiators, targets, and the switching fabric. Common issues include incorrect zoning, LUN visibility problems, or failed interfaces. Tools like fabric maps and path verification utilities help administrators trace the communication path and identify where disruptions occur. Monitoring tools may also report packet loss, excessive retransmissions, or protocol errors that signal deeper issues. Effective troubleshooting demands a solid understanding of both the storage protocol in use and the topology of the SAN itself. Fiber Channel over Ethernet, or FCOE, is a technology that enables fiber channel traffic to run over standard Ethernet networks. This allows organizations to consolidate their networking and storage infrastructure, reducing the number of cables and switches required. FCOE requires data center bridging support to ensure lossless transmission, which is critical for SCSI traffic. While FCOE reduces hardware complexity, it introduces challenges related to configuration and compatibility. It is often used in converged infrastructure deployments where performance and space efficiency are priorities. Choosing between ASAN and ANAS depends on the needs of the environment. SANs are best suited for block-level storage use cases that demand speed and low latency, such as databases or virtual machine storage. NAS solutions, by contrast, are ideal for file-level access and are often easier to deploy and manage. Some organizations adopt hybrid models that combine SAN and NAS capabilities, offering both types of access to different workloads. On the exam, you may be asked to evaluate storage scenarios and recommend the appropriate solution based on performance, cost, and complexity. The Network Plus exam covers a range of SAN topics, including the roles of initiators and targets, the function of zoning and masking, and the differences between fiber channel, SCSI, and FCOE. You may also be asked to compare SANs to NAS systems, identify their use in virtualized environments, or troubleshoot common SAN issues. Understanding how SANs operate, how they are secured, and how they scale will prepare you to answer both factual and scenario-based questions confidently. A storage area network delivers block-level storage access across a dedicated high-speed network. It is a foundational component of enterprise data centers and virtualization clusters, offering the performance and flexibility needed for modern computing environments. From protocols like Fiber Channel and iSCSI to features like zoning, multi-pathing, and centralized management, SANs combine specialized technologies into a powerful storage solution. Mastering SAN concepts prepares you not only for success on the exam, but also for designing and supporting high-performance storage systems in real-world networks. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.